Welcome to Summarize Science. Have you ever tried to take a video of a moving object and wished you could see it from any angle? Creating a full 3D, or even 4D model that moves over time from a single video is incredibly difficult. This is especially true when parts of the object are hidden or when you want to see it from a completely new perspective. Existing methods, like Dynamic Gaussian Splatting, try to solve this by representing the scene as millions of tiny, colorful 3D blobs called Gaussians. The problem is, these methods often treat every single blob with equal importance. This means a blob that is clearly visible is treated the same as one that's hidden behind something or only seen for a split second. This can lead to weird distortions and motion drift, where the model seems to fall apart when you look at it from a new angle. Researchers from Texas A&M and Mercedes-Benz North America realized that, just like us, a computer should be more confident about what it can see clearly. They introduce a new framework called Splat4D, which is built on a simple but powerful idea: uncertainty matters. The system first analyzes the video and gives every single Gaussian blob an uncertainty score for each moment in time. Blobs that are seen clearly and consistently get a low uncertainty score, meaning they are very reliable. Blobs that are occluded or barely visible get a high uncertainty score. Then, the clever part: the system identifies the most reliable, low uncertainty blobs and treats them as key nodes or anchors. It builds a kind of spatiotemporal graph, like a strong skeleton, connecting these reliable anchors through space and time. The less reliable parts of the model are then guided by this reliable skeleton, ensuring they move consistently and don't just drift away. This process essentially propagates motion information from the parts the AI is sure about to the parts it is unsure about. So, what are the results? Looking at these comparisons, the difference is clear. The older methods on the left struggle with extreme viewpoints, resulting in blurry or distorted figures. But Splat4D on the right produces much more accurate and consistent reconstructions, even from angles the camera never saw. They tested this on real-world videos and a synthetic benchmark they created called Objiverse. On the Objiverse dataset, the improvements were most obvious at extreme angles, sometimes showing a completely stable object where the old method's model had collapsed. So, to recap, this research introduces a smarter way to reconstruct moving 4D objects. By calculating the uncertainty of each tiny part of the scene, the model can build a reliable skeleton to guide the reconstruction. This prevents the model from falling apart when viewed from new and extreme angles. In the future, this technology could lead to much more realistic and robust augmented reality applications. It could also improve simulations for robotics or allow for easier creation of high-quality 3D assets for games and movies, all from a single camera. That's all for this episode. Thanks for watching Summarize Science.